So let's talk about chemical formulas now, and how they're going to be related to the previous video on moles, mass, and atoms. So let's take a look at a couple compounds, CO2 and CO. So if you're given a chemical formula, there's a few things you need to be able to do with this. First is build up a conversion factor between the mass and moles, and the second is to be able to develop atomic and molecular ratios. So the ratio of atoms of C to O in these molecules, or C to CO2, or O to CO2. So let's talk about the weight first. Now, molecular and atomic weights are very easy to work with. So carbon, if we look in the periodic table, has an atomic weight of 12.0. Oxygen has an atomic weight of 16.0. What the chemical formula tells us for CO2 is that it takes one carbon atom and two oxygen atoms to make up a single molecule of CO2. So if we want to figure out the weight of CO2, all we have to do is add up the weight of the individual atoms. So we've got 12 due to carbon, and we've got two oxygens, so this is twice 16, so this will give us 44.0. So what are the units on this 44.0? Well, this is your first conversion factor. This is how you go from mass to moles. So this is 44.0 grams of the compound divided by moles of the compound. So when you add up the atomic weights, the number you get is the grams of the molecule divided by moles of the molecule. How about carbon monoxide? Well, we got 12 due to carbon, 16 due to oxygen, so it's going to be 12 plus 16. So this will give us 28 grams of the compound, CO, for 1 mole of CO. And now we've got our ability to convert between mass of the compound and moles of the compound, this gram to mole ratio. If we are going, like I said in the previous video, from mass to moles, we're going to divide by this number. This will put grams in the denominator. If we're going from moles to mass, we're going to multiply this number because it's going to put moles in the denominator. Now the other thing we have to be able to build up are the ratios between the individual elements of the molecule. So how do we do that? If we want to convert between atoms and molecules, meaning that we want to know atoms is something and a molecule is something, our denominator is always 1 mole of the molecule or 1 molecule. So always be in our denominator. And we'll go through at the end of this video when you want to use these conversion factors. The numerator is going to be whatever the subscript is on the atom you're interested in. So let's say we want to do carbon. So for every mole of carbon, there's 1 mole of CO2. For every atom of carbon, there's 1 molecule of CO2. The distinction here is that we're working in moles on top and atoms and molecules on the bottom. Let's say we want to work with oxygen. Oxygen has a 2, so this is just going to change this number to 2 moles of oxygen or 2 atoms of oxygen per molecule of CO2. For the bottom one, our parent molecule, 1 mole of CO or 1 molecule of CO. And it depends on what we're interested in. Let's say we're interested in oxygen. We have 1 mole of oxygen because we have 1 atom of oxygen, or 1 atom of oxygen for every molecule of CO. So when do you want to work with these conversion factors? These top two, the mole to moles, get worked out when you're in units of moles. So if you're already in moles and you want to convert between the atom of something and a molecule of something, that's when you're going to use this conversion factor. If you are already in numbers, meaning that you've got molecules or atoms, that's when you're going to use this conversion, these two conversion factors. So the atoms of oxygen per molecules of CO2. If you're working with large powers of 10, you'll be in the molecules of something or atoms of something. Now, let's say you're given a problem and you're asked to convert between atoms of carbon and atoms of oxygen based off of a chemical formula. So let's say you got 6.02 times 10 to the 23rd atoms of carbon. You want to know how many atoms of oxygen you have for a CO2 mixture. To do this, the conversion factor, if you're in moles or atoms, is always going to be the ratio of their two coefficients. So there are 2 moles of oxygen for every 1 mole of carbon in this compound. Or there's 2 atoms of oxygen for every 1 atom of carbon. For the second compound, carbon monoxide, there are 1 mole of oxygen for every mole of carbon, or 1 atom of carbon, 1 atom of oxygen for every atom of carbon. Again, you're going to work with these mole ones if you're already in units of moles. And you're going to work with these bottom two, the atoms and atoms, if you're already in numbers. So here's how, based off the chemical formula, you can build up your conversion factors between mass and moles, going off the molecular weight, or atoms and molecules, or atoms and atoms, depending on where you are in terms of working with moles or atoms.